Right. Today we'll see how to control a DC motor, right? So we'll write an 8051 assembly level code to control a DC motor, right? So basically that is our objective. The tool what we are going to use is EDSIM51. Using that simulator, we are going to control the motor, right? So when we talk about the control of the motor, we can perform like both speed control as well as direction control. Both can be performed, right? So we'll do one after the other, right? Okay. So before doing that, we need to understand how the circuit actually works, right? We need to understand how the circuit actually works. Actually, this is a H bridge circuit, right? This is a H bridge circuit because it is taking a shape of a H, right? Here, if you see, these two will form one leg of the H, the other leg of the H, and then the center one. So this is how that is the reason why it is called as H bridge, right? So we are using this H bridge to control the motor. Both speed as well as direction can be controlled, right? So if you could see, we are having like PNP type of transistor as well as NPN type of transistors are there, right? So using such kind of transistor, we can control both to say speed as well as direction, right? And we have two control signals, right? These two are A and B are called as control signal, right? By giving the value here, right? Either you give 0 or either you give 1, you can control the direction of the motor, right? You can control the direction of the motor. Let's see how we can operate the motor in one direction, right? So since we have two bits, right, I can take A as one bit and B as another bit. If I take two bits, right, if I change the value, right, if I change these values, I'll be able to start, stop, right, rotate in forward, rotate in reverse. I can do all the operation, right? So basically, if you give both the inputs as same, right, if both the inputs are same, the motor is not going to work, right? That means the motor is not going to run. It will remain standstill. So difference in input, right? If A is different from B, then the motor will start to rotate, right? Motor will start to rotate either in clockwise direction or in anti-clockwise direction, right? Let's assume that for A I am giving 0 and B I am giving 1, right? As of now, you don't need to worry about this. What is this P3.1 and P3.0? I'll come to that later. But let's understand what will happen if I make A as 0 and B as 1, right? So in this slide, I have made A as 0 and B as 1, right? For your information and for you to recollect, in a PNP transistor, if the voltage, right, if the base voltage is lesser than the emitter voltage, right, emitter is here, you have the emitter. So if the base voltage is lesser than the emitter voltage, then this transistor will turn on, right? Then the transistor will turn on. Normally we connect this particular terminal to VCC, right? And this one to ground. That's shown by the symbol, right? So VCC. So when I make this terminal B or the control pin A as 0, control pin A as 0, this transistor Q1 turns on, right? Q1 turns on, right? And current starts to flow from VCC through the transistor and it comes here. It goes through the motor, right? And then again, this is an NPN transistor. So this voltage should be, what to say, the B is made as high. So again, Q4 turns on, the current will start flowing, and this is how the current flows in the case of one direction. Say for example, this is forward direction. So this is how current is going to flow. What happened to the other two transistors, Q2 and Q3? They remain off, right? They remain off because when you give 1 at B, Q2 is off. When you give 0, Q3 will be off, right? So this will be at one direction, right? Okay, so now when you actually change the value, right? Now you are changing the value, that is making A as 1 and B as 0. Now Q3 will turn on, right? Q3 will turn on, and if you see Q2 will also turn on. Now the current will flow like this. Now if you see the direction in which the current is going to flow inside the motor is going to change. So that's how we change the direction of the rotation of the motor, right? That means changing the direction of the current flow in the motor, we are achieving the direction control in the motor, right? Changing the current direction of the current direction in the motor, we are changing the rotation, right? Direction of rotation of the motor. So keep this thing in mind. This is the clue, right? Fine. So now we are going to connect this bridge driver, right, which is going to provide the supply, for the motor, right? As of now, we are not using the motor sensor, right? Motor sensor is connected to pin 3.5. We are not using this part, but what to say? This is this particular picture that I have taken it from the same EDSIM, right? EDSIM catalog, right? EDSIM manual, EDSIM 51 manual. I have taken this picture from there. So there they have written a code, right? There is an example program. In that example program, they have used the sensor to sense the speed of rotation, right? As of now, in our case, we are not going to use it. If you want, you can use it, but it requires the knowledge of the timer, right? Since we are not dealing with the timer as of now, I have omitted that part. Maybe if we get time, we may implement this particular exercise with timer, right? If time permits, right? Because of the lack of time, I have modified the code and I removed the timer from there and then made it work. So now you don't need to worry about the motor sensor because we are not going to use it. Now if you see here, B pin is connected to port 3.0. That means in 8051 at port 3, bit number 0, this control signal B or control pin B is connected. Control pin A is connected to pin 3.1. Control pin A is connected to 3.1. That's where I have used it within the bracket so that you can understand. Now I think you can understand it easily. So when the inputs are similar, there won't be any rotation of the motor. When the inputs are going to differ from each other, either you'll have forward direction or you'll have reverse direction. That depends upon the value that you put in the pin, control pin A and B. Right? Okay, let's do a simple exercise where I'm just going to make the motor rotate in one direction, right? So select the preferred direction of rotation of the motor, right? So how do I select it? I should make pin 3.1 as 0 or pin 3.0 as 1. That means I may select forward direction. If I select forward direction, then pin 3.1 is supposed to be 0, then pin 3.0 is supposed to be 1. So let's go ahead, right? Now I have selected that I want the motor to rotate in forward direction. For that, I have to make this pin 3.1 and pin 3.0 as 0 and 1 respectively. Then I have to create a delay loop, right? Create a delay loop and then repeat this operation, right? So that means I need to make pin 3.1 as 0, pin 3.0 as 1, right? Once I do this, then the motor will rotate in forward direction, right? And again I have to repeat this, right? Repeat giving this value to the output port, or I can when I keep on doing this, the motor will keep rotating in one direction, right? Okay, so we'll see this particular exercise now, right? We'll see this particular exercise now before I give you the actual task for this day, right? Let me load the program. So this is as, let me, are you able to see my screen? Students, are you able to see my simulator screen?
Yes, sir.
Okay. So here, here I have used the command set B and clear, right? Set B will make pin 3.1 as what should I do for pin 3.1? Okay. So 3.0 and this is 3.1. Okay. So what I did, I selected the mode of operation. So this is how I select the mode of operation. I want the motor to rotate in forward direction. Then I have used two registers, right? I have used two registers, R0 and R2, right? And then I have created a delay, right? So what these two instructions are going to do, it is going to decrement R0 register. If the R0 register has not become 0, I'm going to repeat this loop, right? I'm going to repeat this loop. Similarly, S2, right? I'm going to repeat this loop. If you want, you can add, or if you don't want, you can remove this, right? This is just to create a delay so that you'll be able to see the speed at which the system is going to operate. Then I'm going to repeat it. S jump, SP. That means after when this line comes, it will go back and then start executing this line. That means this is going to get repeated, right? This is going to get repeated, right? Let me start the simulation. Let me say run. Now you can see on the right bottom, you can see the animation, right? It is rotating in the clockwise direction, right? There is a slider. You can gradually bring it down. Here, this slider actually doesn't do anything actually directly connected to the program. It is just connected to this animation, right? The animation can be slowed down, or it can be made faster, right? So you can control the speed of the animation, right? So say for example, I just so this slider doesn't have any control over the program, right? This slider has a control only for the animation, right? So if you want to, so what you can do, you can keep the slider at maximum, right? You can maximum or in minimum position, any extreme. Then you can keep changing these values, and you can see how these values are getting updated, right? So this is how the code for direction, how to say, rotation comes, right? Okay, let me change the value now. Now, can somebody say in which direction this motor is rotating, clockwise or anti-clockwise?
Clockwise.
Okay. Clockwise. Okay, good. So let me change this value, right? So if you see here, the screen is in gray color, then I may not be able to edit it. So I have to press reset to make sure that the screen becomes white, right? Then only I can edit it. I'm changing the state of these pins, right? So I'm just changing the state of the pin, and I'm going to run the code. Now you tell me what is the direction in which the motor runs.
Anti-clock.
Right. Okay. So this is how we are going to control the direction of rotation. Right. Now I'm going to give you a task now. There are switches here, right? I am highlighting the switches on the left middle, right? Left bottom almost, right? You have like 0, 1, 2, 3, 4, 5, 6, 7. There are 7 switches are there, right? So there are 7 switches. Basically, these switches are connected to port 2, right? P2. They are connected to port P2, right? Now the task is, when I press a switch, it has to rotate in one direction, right? When I depress the switch, it has to rotate in other direction. That means by default, the motor can rotate in one direction. But when I press the switch, the direction should be reversed, right? That's the task I'm giving, right? Let me see who finishes this exercise first, right? And once you finish, you are welcome to leave, right? I'll mark the attendance. This is the task for you, right? This is a simple program. Again, I repeat the task. I just repeat the task. When you don't press the switch, right? When you don't press the switch, the motor has to rotate in one direction. But when I press the switch, the direction of rotation should be reversed. Direction of rotation should be reversed. That means you need to sense the position of the switch, right? So for that, I'll give you a small clue, right? Please make a note of it. When I press the switch, right, the value of that switch will become 0. That's how it has been configured. I'll show you with the spec sheet. I'm sharing the spec sheet for you so that you'll be able to see. Are you able to see the spec sheet? Right. I'm just sharing this link also in the chat box. Here. Okay, in the chat box I have shared this link. You can also refer that, right? So if you see here, right, here the switches SW0, SW1, they are all switches. These switches, when you close the switch, what will happen? The value will become 0. When the switch is open, then the value is actually high, right? So that's how the switches are configured, and they are connected to port 2. They are connected to port 2. Now the task is, you need to select any one of the switch, right? You can choose any one of the switch out of these 8, and when you press the switch, the direction of rotation has to change. So that's the task, right? Let me see who comes with the output at the earliest, right? If there is any question, you can ask me now.